The first thing I want to talk about is reflection. And then we'll talk about refraction and how does that differ. So I want to talk about reflection at spherical surface. So what kind of spherical surface did we talk about when we talked about reflection? We talked about two things. We talked about a positive lens and we talked about a negative lens. And we said that these were made like that, and these were made like. So since we're talking about a reflecting surface, we're going to be talking about a mirror. So mirrors are what we are concerned about now. Another word I'm going to introduce to talk about it is called the center of curvature. C. What is the center of curvature? The center of curvature is how much the mirror is either concave or convex. The center of curvature can be to the left side or to the right side of the mirror. So when you think about a mirror, actually, this mirror doesn't end here. So let's say if I talk about this mirror, it's easier to see if I talk about a negative mirror. This mirror, I can draw it out so that it's circular, right? So it's in a circle. It has to have a center that defines by how much it curves. That's called the center of curvature. And these points are called normal to the surfaces. So every surface has a particular normal. So any reflecting surface will have a normal to the surface. So now let's look at this particular type of surface and we'll talk about how this works. So if I have a point source, how will this particular scenario work out? I'm going to try to be careful. So imagine this is my optical axis. So this is the reflecting surface I'm going to draw. If my object is here, it is emitting light in all directions. So I'm going to take two particular rays and I'm going to talk about them. The first ray that I'm going to talk about is a ray that is normal to the surface at this point. This point is called the vertex. What will happen to this ray? It will in fact be reflected back onto itself. But imagine what happens if the ray is incident at point P. The ray will go like this. And because it is going to be reflected back, by how much it is going to be reflected back depends on the center of curvature. Remember, I said that there were normal lines to the surface from the center of curvature. And we know that our law of reflection says that this angle, theta I, must equal the amount by which it is reflected back. So this is theta R. I know law of reflection says theta I equals theta R. May I call both of them thetas? Okay, so that means this ray goes in here, hits point P, and then gets reflected that way. Where the dotted line is the normal to the surface. May I extend this reflected light ray back. Can I do that? I'm going to call this point I. And since I cannot ignore the thickness of the lens, I can redraw this line back, the green one, and I'm going to call this point Q. I'm going to erase these so we're not getting confused. So I'm going to start naming angles, okay? So the first one I'm going to call blue. This angle, I'm going to call it alpha. This angle, I'm going to call alpha prime. And that angle, I'm going to call phi. So now, if I call the height, the length of the green line H, may I write the following? Sine of phi equals H over R, where R is this distance between C and the surface. May I also write tangent of alpha as H over S, where I call this distance S. May I also call tangent of alpha prime as H over S prime, where I call this distance S prime. Notice I am not calling them O's and I's yet, because technically this is where the objects and the sources are, the images and the objects are, right? Because they're technically not the object distance, because they should be measured from the surface. We'll convert them because they're very close. The line is going to be, the thickness of the lens can be ignored with respect to everything else, but I'm not ignoring that right now. So I'm calling them S and S prime. We know that our ray, if I call this ray 1 and call this ray 2, can I say this about my ray 1? That this is normal to the surface at vertex, which is a central point on the surface with the optical axis, and it reflects back onto itself. And for ray 2, can I say that it obeys the law of reflection? It diverges as it is reflected, and it gives me an image at point I, which is virtual. Remember, it was easier to see when we had an extended object, but now that we have a point source, the image will be created at I, and it will be a virtual image, right? How do we know it's a virtual image? Because we cannot project it onto a screen. It's behind the mirror.